Good morning, students. Today we're going to start with a fresh chapter. The chapter's name is Fractions and Decimals. It is the second chapter, right? So, first let's understand what are fractions, okay? Now, imagine that this is a cake, okay? What is this? This is a cake. Now, I have divided this cake into equal parts. How many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 equal parts. What kind of parts? Equal parts. 8 equal parts, right? Now imagine that I took out one part from this cake, okay? So look, the eighth part I have taken out from this cake. Now, how do I represent this eighth part? How do I represent this one part in mathematics? I can represent it as 1 out of 8. Can I represent it as 1 out of 8? Because it was 8 completely, right? And then I took out one part. So it was 8 first, and this is one part out of 8 parts. So how do I represent that? 1 out of 8. So can you see 1 by 8? 1 out of 8, right? Now imagine I took out one more piece. Now I have two pieces outside. So how many pieces? The first piece also I have. The eighth piece also I have. So how many pieces do I have? Two pieces. And two pieces are out of how much pieces? Out of 8 total pieces, I took out two pieces, right? So how can I represent this in mathematics? So how do I represent this? I represent this as 2 out of 8, right? Why? Because there are two pieces. And how much out of is this two pieces? These pieces are 2 out of 8 pieces, right? And we can do this only when the pieces are equal. Okay, remember the point? I have divided this cake into equal parts. That's why I can write it as 2 out of 8. Why? Because this is 2 equal parts out of 8 equal parts, right? So 2 out of 8. Now look at this. Now, instead of taking out any pieces, if I did not take out any pieces, how can I represent this entire cake in a form of fractions? Can I represent it as 8 out of 8? Yes, I can represent all these pieces together as 8 out of 8. Now, we know that 8 out of 8 is division, right? So when I divide, how do I cut it? 8 ones are 8 and 8 ones are 8. So what do I get? 1 by 1. And what is 1 by 1? It is 1, right? So that means in a fraction, when we represent the number or when we write the number 1, what does it mean? It means total. Okay, so 1 means total in fraction. Okay, so 8 out of 8 becomes 1, and 1 means what? 1 means total in fraction. Okay, so now keeping this in mind, let's see. A fraction has two parts. What are the two parts? Okay, so keeping that in mind, fraction has two parts. What are the two parts? The two parts are numerator and denominator. The number that we write on the top of the fraction is called the numerator, and the denominator is the number that we write on the bottom part, right? So now look, numerator means what? It represents the part, okay? It represents the part, one part or two part or three part out of how much? Out of the total. So denominator shows us the total and numerator shows us the part, okay? Now, let us study the types of fractions. There are different types of fractions, right? So the first type of fraction is called proper fraction. Okay, what is the first type of fraction? Proper fraction. Now, we know that a fraction looks like this, numerator by denominator. Now, what is proper fraction? Proper fraction means the fraction which is of the form numerator by denominator. And it has a speciality. What is the speciality? Numerator is always less than the denominator. So numerator will always be a smaller number than the denominator, okay? So that is called proper fraction. So let's look at some examples. 1 by 2, look at this example. Here we know that 1 is less than 2, right? 1 is less than 2. So we can say that 1 is less than 2. So numerator is less than denominator. So this is a proper fraction, right? Now another example, minus 2 by 3. Now you can see that minus 2 is less than 3. So you can see that minus 2 by 3 is again numerator by denominator, and numerator is less than the denominator, right? So this is also a proper fraction. Now another example, 30 by 31. So you can clearly see that 30 is less than 31. 30 is a smaller number than 31. So numerator is less than denominator. So whenever this condition is satisfied, that is numerator is less than denominator, then that type of fractions are called proper fractions. Okay. Now let us look at the second type of fraction. Second type of fraction is called improper fraction. Okay. What are the second type of fraction called? Improper fraction. Now, what is the speciality of improper fraction? Improper fraction also looks like numerator by denominator, definitely, because it is a fraction, right? Now, any fraction looks in this form, numerator by denominator, right? So, improper fraction also looks like numerator by denominator, and this form has a speciality. What is the speciality? Numerator is going to be always greater than the denominator. So it is the opposite of proper fraction, right? So improper fraction is the opposite of proper fraction. So improper fraction, what is it? Numerator is always going to be greater than the denominator. So let's look at some examples. 5 by 2. You can see that 5 is greater than 2. So definitely 5 by 2. 5 is greater than 2. So numerator is greater than the denominator. So it is an improper fraction, right? Now another improper fraction, 9 by 7. Can you see this? This is another improper fraction where the numerator is greater than the denominator. So definitely this is also improper fraction, right? Now another example, 38 by 12. So you can see 38 by 12. Again, numerator is greater than the denominator. So this is also improper fraction, right? So improper fraction means what? The fraction where the numerator is greater than the denominator is called improper fraction. So all these are examples of improper fraction, okay? Okay, so now the third type of fraction is called the mixed fraction, okay? So what is mixed fraction? Let's see. First, we write a whole number, then we write numerator and denominator. So this is how we form a mixed fraction, okay? This is mixed, right? You can see there's a whole number first, and then you write the numerator and the denominator. Now you can see that this is a fraction. Numerator by denominator part is a fraction, right? And what type of fraction this should be? The condition is that this should be a proper fraction always, okay? What type of fraction should this be? This should be a proper fraction always. Okay, so let's see some examples. Now 3 is a whole number, you know that, right? And 1 by 2. So you can see there's a whole number, there's a numerator, and there's a denominator, right? So whole number, numerator, denominator. So this is 3, 1 by 2 is a mixed fraction, right? Now you can also see that the condition is satisfied. What is the condition? 1 by 2, which is 1 by 2 is a proper fraction. Why is it a proper fraction? Because 1 is less than 2. Numerator is less than denominator. Then it's a proper fraction, right? So you can see that this is a whole number, numerator, denominator, and this fraction is a proper fraction. So definitely this whole thing, 3, 1 by 2, we call this 3, 1 by 2. So we pronounce this as 3, 1 by 2, right? So this is a mixed fraction, right? Now let's look at another example. Now the next example is 1, 6 by 9. You can see 1, 6 by 9. So 1 is a whole number, 6 by 9 is a fraction. What type of fraction? Proper fraction. So there's a whole number, there's numerator, and there's denominator. So 1, 6 by 9 is also a mixed fraction, right? Now another mixed fraction, 2, 3 by 5. So 2 whole number, 3 numerator, 5 denominator, and this is a proper fraction, 3 by 5, because 3 is less than 5. So this is a proper fraction. So this whole thing, 2, 3 by 5 is a mixed fraction, right? So these are all examples of mixed fraction, okay? So this is what mixed fraction is. There should be a whole number, there should be a numerator, and there should be a denominator, and this part should satisfy that this should be a proper fraction, right? Now the next type. So after studying mixed fraction, we are going to see how to convert a mixed fraction into a regular fraction. Okay, so we have to convert this mixed fraction into a regular fraction, normal fraction. Okay, so how do we convert? Let's see. 3 1 by 2. This fraction is 3 1 by 2. So how do I convert it? Look here. First, I should take these two numbers. Okay, can you see these two numbers that I've circled right now? Yes. First, you take this number and you multiply them. Can you see I multiplied them here? 3 into 2. Then with that you add this part. Okay, so what is that? You add that part, right? So what did I do? First I took these two numbers, that is 3 and 2. First I took these two numbers and I multiplied them, right? Then I took this number and I added them. So what is the process? The direction of the process is what? From here you go to this side. And how do you go? First you multiply, then you add. So this is the method of converting. Okay. So now next what step do you do? This step. You have to do this step, right? So how do you arrive at that step? 3 into 2 first. You have to do the multiplication always. So 3 into 2, 6. Right, you can see there's 6 here, right? So you can see 3 into 2, you get 6. Then you do 1 plus 1 you have here, so plus 1, and 6 plus 1 is 7. Then the denominator remains the same. Denominator is 2 here, so that same denominator is 2 here also, right? So let's look at it once more clearly. So you can see what is the direction? This is the direction. So what do I do first? First I multiply this 2. The whole number and the denominator I multiply it. So 3 into 2, 3 into 2 plus the numerator. So plus 1. So 3 into 2 is 6 plus 1. 6 plus 1 is 7 and the denominator remains the same. 2, 2, 2, 2. So this is the fraction that we got, the regular fraction that we got, right? So the mixed fraction, I converted into normal fraction. So mixed fraction, when I convert it into a normal fraction, what type of fraction did I get? 7 is greater than 2. So what type of fraction is this? Improper fraction. So you can see that when I convert a mixed fraction, I get an improper fraction. So that means 3 1 by 2 is equal to 7 by 2. So what did I get right now? 3 1 by 2 is equal to 7 by 2. This is what I got right now, right? So these two are equal, this and this. This is the improper fraction form and this is the mixed fraction form, right? So I converted this mixed fraction into an regular or normal fraction, which is a improper fraction, right? Now let me show you one more example to make it thorough. Look at this example. We have the number 1 6 by 9. So how do I convert? First I take the whole number and the denominator and multiply them, right? So 1 into 9. So what did I get? 1 into 9. Then what number is left? I have to take that and add it. So I have added that 6, right? So 1 into 9 first, multiplication, then add the numerator, right? So first what did I do? I multiplied the whole number and the denominator and then I added the numerator. And what is the denominator? Denominator is the same denominator, 9 itself, right? So 9 repeats, right? So that is what I did. So you can see here. So what is it? 1 into 9 plus 6. So now multiplication first. 9 into 1, 9. 6 plus 6 will be plus 6 itself. 9 plus 6 is 15 by 9, right? So 15 by 9. So 1 6 by 9 is actually what? 15 by 9. So I can say that 1 6 by 9 is the mixed fraction, which I converted it into a improper fraction. What type of fraction? Improper fraction. What is the improper fraction? 15 by 9. So 1 by 6 is equal to 15 by 9 because I converted 1 by 6 into 15 by 9. You can see that here, right? So this 15 by 9 is what type of fraction? Improper. Why? 15 is greater than 9. You can see that 15 is a greater number than 9, right? So what type of fraction is this? Improper fraction, right? So once more, look carefully once more. First, I took a mixed fraction. How do I convert it into an improper fraction? How do I convert a mixed fraction into an improper fraction? First, I multiply the whole number and the denominator, 1 into 9. So 1 into 9. Then I add the numerator, plus 6, plus 6. Then the denominator remains the same. 1 into 9 becomes 9. Plus 6 becomes plus 6 itself. 9 plus 6 becomes 15. Denominator remains the same. So 15 by 9. So I can see that the mixed fraction, I converted it into a improper fraction, right? So, okay, so in the previous part, what did we do? We converted a mixed fraction into an improper fraction, right? We converted a mixed fraction into an improper fraction. Now we are going to do the reverse process. How do we convert an improper fraction into a mixed fraction? Let's see. Now look at this. 7 by 2. Is it an improper fraction? Yes, it is an improper fraction, right? Because 7 is greater than 2. Numerator is greater than denominator. So definitely it is an improper fraction. Now, how do I convert an improper fraction into a mixed fraction? First, I need one whole number to write here. Then I need to write one numerator. And then I need to write one denominator, right? So how do I find these? How do I find the whole number, the numerator and the denominator? How do I find it? Let's see. Okay. So first, it's 7 by 2. So what do? We divide it. 7 by 2 means we have to divide 7 by 2, right? So let's divide. 2 3s are 6 and I get remainder 1. So I stop my division here. Why do I stop my division here? Because 1 cannot go in 2's table anymore, right? So I stop my division here. So what did I get? 1 as my remainder. Now when I stop my division, I have to go in this direction now. First I take 3, then I take 1, then I take 2. Now you must be wondering, why do I take? Let's see. Where do I take? 3 I'll write first. 3 is my whole number, okay? Then I write 1. So can you see in which direction am I going? 3, 1 by 2. Can you see in which direction I went? I went in this direction. First I went from 3, then I went to 2, 1. Then I went to 2. Can you see that? 3, 1 by 2. So can you see that? 3, 1 by 2. So that is the direction I went in, right? So let's look at the direction once more. 3, 1 by 2. So this is the direction I went in, okay? So that is how we have to solve and make this improper fraction into a mixed fraction. So let's see one more example. 15 by 9. 15 by 9. How do I solve 15 by 9? 9 will divide 15, right? So 9 how much? 9 2s are 18, so I can take 9 1s are 9, right? So what do I get as remainder? 6. Now can 6 go in 9's table? No, because 9 1s are 9 itself, so bigger than 6, right? So 6 cannot go in 9's table, so I stop my division there. And what do? I go in this direction. Which direction? This direction. So what number do I write first? I write 1, then I write 6, right? First I write 1, then I write 6. 6. Then below I have to write the last number, which is 9. So can you see 1 6 by 9? So 1 6 by 9, right? So this is how you convert an improper fraction into a mixed fraction. Now let me show you something. So when I converted this, what did I get? I got 3 1 by 2, right? I got 3 1 by 2. Now let me check whether this is correct or not. How do I check? we have already learned how to convert a mixed fraction into an improper fraction before, right? So let me convert this mixed fraction. So how do I convert? First I take 3 and 2 and multiply it, and then I add the numerator 1, right? What did I do here? First I take 3 and 2 and multiply it, and then I add the numerator 1, right? So that is what I did here. Then I divide and I write the same denominator. So what is the denominator? 2. So I write 2 itself, right? So now let me solve this. 3 into 2, 6 plus 1 divided by 2. So what did I get? 7 by 2. So can you see, when I solved the mixed fraction, right? What was the mixed fraction that I got? 3 by 2. So when I solved the mixed fraction, I got the same improper fraction. What improper fraction? 7 by 2. So what was the question? 7 by 2. So can you see, when I solve 7 by 2, I get this. And when I solve this, I get this. Yes or no? So that is what converting an improper fraction into a mixed fraction is. Okay? So same way, if I convert this, what did I get for this? 9, 6 by when I divided it, I got what did I get? 1, 6 by 9, right? So now look, same way like I showed you in the previous one, let me convert this. How do I convert it? First I take 9 and 1 and I multiply them, right? So 9 into 1 plus 6 divided by 9. So 9 into 1 is 9 plus 6 by 9, and 9 plus 6 is how much? 15 by 9. So can you see 15 by 9? So I got 15 by 9 itself. So basically what I want to tell you here is, so you can see that when I converted this, I got this, right? And when I converted this, I got this. Likewise, when I converted this, I got this. And when I converted this, I got this. So can you see? So that means a mixed fraction, when I convert it into an improper fraction, I'll get the same thing when I convert this improper fraction into this mixed fraction. So that means this is the reverse process, right? So you need to keep this in mind, okay? So when I convert a mixed fraction, I'll get an improper fraction. When I convert an improper fraction, I'll get a mixed fraction, okay? So that is what you have to keep in mind. And it's a very simple process, right? If you understand it, okay? So please make sure that you watch the video again and again in this part and understand this. Now the next thing. So let me summarize it. What was the process of conversion? First you have a mixed fraction. Mixed fractions of the form whole number, numerator by denominator, right? And what is the formula for conversion? How do I convert this mixed fraction into an improper fraction? How do I convert it? First I take the whole number and the denominator and I multiply them, right? So I multiply them, look here, whole number into denominator, right? And then I take the numerator and I add it. So numerator, and I added the numerator. And the denominator remains the same denominator, right? So that is what we have done here. So you can see here clearly. First the whole number into denominator, I get here whole number into denominator. Then I take the numerator and I add it, and then the denominator remains the same. So this is the formula for conversion of a mixed fraction into an improper fraction, okay? Now, the last type of fraction that we're going to study today is equivalent fraction. Now, before studying equivalent fraction, look at the word equivalent. What does equivalent mean? Equivalent means equal in value. Now, how do you understand this? What is equal in value? Now, imagine you have a gold block, okay? You have a biscuit of gold. Biscuit of gold means a gold block, okay? And this gold block cost rupees 20,000, okay? And imagine you have another block of cash. You have money in your hand, and that money, how much value does it have? 20,000. So you have two things. One is 20,000 rupees costing gold, gold which cost 20,000 rupees. And another one is you have money. You have notes which are adding up to 20,000, right? So can you see that gold and money are both different things? They are different things, right? But their value is the same. Can you see their value is the same? Yes. So that means gold and money are equivalent. Why? Because their values are same, but they are different. So can you see that? So that is what equivalent means. Equivalent means equal in value, but they are different. So can you see the values are equal, right? 20,000, 20,000. So their values are equal, but their physical forms are not equal, which means they look different. They are different, but their values are the same. Okay. So what did I say? Equivalent means equal in value. Now to understand that, let's take a gold block. Suppose you have some gold block in your hand, and that gold block cost 20,000. Now in another hand you have money, and that money also is 20,000. So you can see that the value of this gold is 20,000 and the value of this money is 20,000 as well. So the values are same, but the commodities or the objects or the elements are different. One is gold, other is money. So these are two different things with the same value. So therefore we can say that the gold block and the money are equivalent. So that is what equivalent means. Equivalent means equal in value. Okay. So keeping this in mind, let's see what an equivalent fraction is. Now look at this fraction 2 by 3. It is a fraction, right? Now, one thing that you need to understand before we start this is that whenever you have a fraction, you have the numerator and the denominator, right? So whenever you have a fraction, that is a numerator and a denominator, whatever you do to the numerator, you have to do to the denominator also. That is, if you add a number in the numerator, you have to add that number in the denominator also. Okay, if you multiply a number in the denominator, in the numerator, you have to multiply that number in the numerator also. Okay, and if you subtract a number in the numerator, you have to subtract that number in the denominator also. Okay, so that means whatever you do to the numerator, you have to do that to the denominator also. So you have to, if you add a number, you have to add it to the denominator also. That is, if you add 1 to the numerator, definitely you have to add it to the denominator also. If you subtract a number, suppose you subtract 2 from it, then you have to subtract it from the denominator also. If you multiply a number to the numerator, suppose you multiply 3 to the numerator, you have to multiply 3 to the denominator also. So whatever you do to the numerator, you have to do it to the denominator also. Why? Because only then there will be no net change. There will be no net change. Net change means what? Total change. Okay, there will be no change in the numerator, in the fraction. Sorry, there will be no change in the fraction. So let me show you one example. So 3 by 8, is it a fraction? Yes, 3 by 8 is a fraction, right? Now this 3 by 8, suppose I want to add 1 to the numerator. Okay, I have to add 1 to the denominator also. Okay, so suppose I subtract 2 from the numerator, then I have to subtract 2 from the denominator also. So you can never do this. You add 1 to the numerator and you just leave the denominator as it is. No, this is completely wrong. You can never do that. Whenever you are working with a fraction, make sure that whatever you do to the numerator, you do it to the denominator also. And whatever you do to the denominator, you do it to the numerator also. Now let's take the specific case of multiplication. Okay, suppose this is a fraction, 3 by 5. Is it a fraction? Yes, it is a fraction, right? Now in 3 by 5, suppose I want to multiply 2 to the numerator. So can I do this? 3 by 2, 3 into 2 divided by 5. Can I do this? No, I cannot do this. Whenever I do something to the numerator, I have to do it to the denominator also. So how will I write this? I can do this. 3 multiplied to the numerator, 3 in the numerator multiplied by 2, then 5 in the denominator should also be multiplied by 2. Now can you see, since it is multiplication, I can cut. So when I can cancel 2 and 2. 2 ones are 2, 2 ones are 2. So what did I get at last? 3 into 1 divided by 5 into 1, right? So what is 3 into 1? 3. What is 5 into 1? 5. So can you see that 3 by 5 is the same as 3 by 5? So basically, I want to tell you only this much, that by showing this, what did I show you? I showed that whenever I multiply the same number in the numerator and the denominator, then the fraction does not change. 3 by 5 stays 3 by 5 itself. Understood? Whenever, what did I say? Whenever I multiply the same number in the numerator and the denominator, then the fraction does not change. For example, I can show you some more. Suppose I write 4 by 8. Is this a fraction? Yes, this is a fraction. Now I multiply 3 on top. What should I do then? 3 should be multiplied below also, right? Numerator and denominator also. So 3, if I multiply on top, I should multiply 3 below also. Now since it's multiplication, I can cut it. 3, 3. So what do I get? 4 by 8 itself. So can you see there's no change? So whenever you multiply the same number in the numerator and the denominator of a fraction, the fraction does not change. It remains the same itself. Okay, so that is what you have to keep in mind. Now keeping this in mind, let's understand what equivalent fractions are. So here you can see 2 by 3 is the example that I've taken. Now 2 by 3, like I showed you before, 2 by 3, I can multiply any number I want to this 2, right? So suppose I multiply this 2 by 2. So I multiplied it by 2. So what should I do? I should definitely multiply the denominator also by 2 itself, right? So if I want to multiply the numerator by 2, I have to multiply the denominator also by 2. So you can see 2 by 3, 2 by 3. I have multiplied this 2 by 3 both in the numerator and in the denominator by 2. So you can see I have multiplied both in the numerator and the denominator by 2, right? So after multiplication, what do I get? 2 into 2 is 4, right? And 3 into 2 is 6, right? So that is what I get. So 4 by 6. Now look at 4 by 6 carefully. 4 by 6. Can I cut it? Can I cut it and make it more simpler? Yes. How can I cut? With 2, right? 2 2s are 4 and 2 3s are 6. So can you see? This is actually 2 by 3. So what did this 4 by 6 become? 2 by 3. So can you see this 2 by 3 and this 2 by 3 are the same? So what I want to tell you is, look here. The value of this 4 by 6 is actually what? 4 by 6 is actually 4, 2 2s are 4, 2 3s are 6. So 4 by 6 is actually 2 by 3 itself. So their values are the same, 2 by 3 and 2 by 3. The values are the same. What is the value? 2 by 3 is the value, right? So the values are the same. But can you see that it looks different? 4 by 6 is different from 2 by 3. They're different numbers. This is 2 and this is 3. This is 2 and this is 3. This is 4 and this is 6. So can you see they look different, right? But their values are the same. Can you see that? The values are the same. What is the value of this? 2 by 3. What is the value of this? 2 by 3. So can you see that the values are the same and they look different? So same way, I'm taking another example. The same 2 by 3 itself I'm taking, and instead of 2, I multiplied 3. So I multiplied 3 on top. So what should I do? I should definitely multiply 3 below also. So I multiply 3 below also. So what do I get? 2 into 3, 6, and 3 into 3, 9. So can you see 6 by 9? I get 6 by 9, right? Now look at this 6 by 9. 6 by 9, I can cut it and make it smaller, simpler. How do I simplify it? 3 2s are 6, 3 3s are 9. So can you see that this 6 by 9 is actually 2 by 3 itself? So can you see what is the value of 6 by 9? 2 by 3. What is the value of 6 by 9? It is 2 by 3. So can you see that both these two numbers, 2 by 3 and 6 by 9, they look different. The fractions look different. This is 2, this is 3, this is 6, this is 9. But when you look at their values are the same, which is 2 by 3 itself. So you can see that this is also 2 by 3 and this is also 2 by 3 itself, right? So the values are the same and they look different. So can you see that this is also 2 by 3, this is also 2 by 3, this is also 2 by 3. So they are all actually equal to one another, right? They're all actually equal to one another. So you can see 4 by 6 is equal to 6 by 9 and that is equal to 2 by 3. So they're all equal to one another. So therefore, but they look different. Can you see? They are all equal but they look different. So when the fractions have the same value, right? When the fractions have equal value but they look different, then they are called what? They are called equivalent fraction. Okay? So this is what we have studied. So what is equivalent fraction? Equivalent fraction means the fraction which looks different, right? The fractions which look different, but their values are the same. Okay? So the fraction which looks different but the values are equal. Understood? So that is what equivalent fraction is. So that means I can say 4 by 6 is equivalent to 6 by 9 and 6 by 9 is equivalent to 2 by 3. 4 by 6 is equivalent to 6 by 9 and 2 by 3. 6 by 9 is equivalent to 4 by 6 and 2 by 3. And 2 by 3 is equivalent to 4 by 6 and 6 by 9. So they are all equivalent to one another. Okay? So this is what equivalent fraction is. Now note one thing. In order to get equivalent fraction, what did I do? I took one fraction and I multiplied the same number above and below. Then I got an equivalent fraction. So in order to get an equivalent fraction, when you are given a number, when you are given a fraction, in order to get an equivalent fraction, what do? You take the same number and you multiply above and below. So what do? You take the same number and multiply above and below. So that is what you do to get an equivalent fraction. Okay? So let's clear it out by seeing one more example. So the last example, you can see that I took the fraction 1 by 2 everywhere, 1 by 2, 1 by 2, 1 by 2. So you can see that all the fractions are the same, right? So what are the fractions? 1 by 2, 1 by 2 and 1 by 2. So 1 by 2, when I multiply it by 2 above and below, I get 2 by 4. Then when I multiply by 3 above and below, I get 3 by 6. If I multiply by 4 above and below, I'll get some other one. So randomly, if I multiply it by 8 above and below, I'll get 8 by 16, right? So I can use any number to multiply, okay? I can use any number here to multiply it. I can use 2, 3, 4, 5, 6. I can use even negative numbers also, -1, -2, -3. I can use any number to multiply, but both the above and below should be the same numbers. Above and below should be the same numbers, okay? That is the only condition. So when I multiply these, what do I get? First one I got 2 by 4. Now, can you look at 2 by 4 carefully? Look at 2 by 4 carefully. 2 by 4, if I cut it and make it the simplest form, what do I write? 2 ones are 2, 2 twos are 4. So actually it is 1 by 2 itself. So can you see 1 by 2, 1 by 2. So what is the value of 2 by 4? It is actually 1 by 2 itself. And what is the value of 1 by 2? It is actually 2 by 4 itself. So can you see both the fractions are equal? Both the fractions are equal value. They have equal value, but they look different. So what type of fraction is this and this? These are both equivalent fractions. So 1 by 2 is equivalent to 2 by 4. 2 by 4 is equivalent to 1 by 2. Same way, I can say that 1 by 2 is equivalent to 3 by 6. And 3 by 6 is equivalent to 1 by 2. Why? Because 3 by 6 is 3 ones are 3, 3 twos are 6. So it's actually 1 by 2, right? So the value of 3 by 6 is also 1 by 2 itself. So you can see values are same, only the numbers are different. So these are both again equivalent fractions, right? So same way, the last one also, understand it. 8 by 16, 8 by 16, if I look at 8 by 16, if I look at 8 by 16, how do I write 8 by 16? 8 by 16, if I cut it, I get 8 ones are 8, 8 twos are 16. So it's actually 1 by 2. So what is the value of 8 by 16? It is 1 by 2, right? So 1 by 2 and 1 by 2. So can you see the values are the same, right? The values are the same, only the numbers are different. So the values are the same. So this, and this, they all have the same value. What is the value? 1 by 2. So they are all mutually equal to one another, right? So this is equal to this, this is equal to this, this is equal to this, then this is equal to this, then this is equal to this, then this is also equal to this, then this is equal to this, this is equal to this, this is also equal to this. So everyone is equal to one another. So you can see that 2 by 4, 2 by 4, 3 by 6, 8 by 16 and 1 by 2. They are all equivalent fractions. So this is how we find equivalent fractions. So to find equivalent fraction, what do? We take the same number and multiply above and below. We take the same number and multiply above and below. Then we get equivalent fractions. And what are equivalent fractions? The fractions which look different but have the same value are equivalent fractions, right? So watch the video again and again, clarify all the doubts, whatever you have, okay? And be ready for the next video, because in the next video we'll be covering from addition and subtraction, then we'll go into multiplication, division, etc. So we're going to cover operations on fractions, okay? So for that, all these things that we have studied in today's video, basic things, you should be definitely clear with it. So please make sure that you watch the video again and again and you have cleared all your concepts, okay? So see you in the next video. Thank you for watching.